looking at a problem like number 20 can be a little overwhelming. So what I recommend you do is look through it, read through it more than one time, and begin to label things. Look at this problem and identify things that are important and draw on the picture. So let's read it. James, also known as Jim Bob, had a rectangular piece of cardboard that was 4 times as long as it was wide. Well, clearly this is 4 times that, based on the way it's drawn. Now, width normally is sideways and length is that way. We're not going to just argue that because you can turn it either way and get the same area. So let's not even go there. But essentially, we don't know what that is. And we don't know what that is. They haven't told us yet, and that might be what they're asking. But we do know this. Whatever this is, if we multiply it by 4, we'll get that. Now, every time I ask this kind of question in class, people say the most ridiculous things. But I'll say things like, if this is x, what's this? And they'll say all kinds of mess, like x to the 4th. Ain't x to the 4th. It's not x plus 4. It's 4x. 4 times x. It's 4 times as big. My word, I got all upset over nothing. Anyway, he wanted to use the cardboard to make a box with no lid. To do this, he first cut 3 by 3 inch square out of each of the 4 corners. Let's just stop right there and draw. Every little square in the corner that he cut out is 3 by 3. 3 by 3. All the way around. Okay? Got that done. We've labeled everything. To do this, he first cut a 3 by 3 inch square out of each of the 4 corners of the piece of cardboard as shown in the picture below. Then James folded the cardboard along the 4 dotted lines shown in the picture. This created an open box with a volume of 336 cubic inches. Let's just think about it for a second. Before we go any further and we start labeling things anymore, let's just stop. 336. It's the first 3 digits of all of our phone numbers. And we know that it is a volume. The volume of what? It's a box. You know this from middle school. It is going to be length times width times height. Okay? Alright, what we're going to do is take this box and we're going to cut that corner out, that corner out, that corner out, and that corner out, and we're going to fold all this up, and we're going to fold this up. And when we do this, I'm going to outline it in green. This right here is going to be the bottom of our box. This problem takes a little bit of visualizing. If I had a pair of scissors on me right now, I would demonstrate it to you. But I don't. And if I left to get them, I'd have to run back. And my mom told me not to run with scissors. I'm not going to do that. Okay, that right there I outlined in green is the bottom of our box. When let's visualize this now. When we fold this up, this becomes the height. So when we fold it, that becomes the height. Well, what's the height? Well, my word, it's 3. That's just going to come in handy. Let's hold on to that thought before we plug a 3 in. Let's get the rest of it in there. So the length and the width. I'm going to call this one the width right here. So what is the width? Don't say x. We want to know what that is. Well, how wide is that right there? Well, let's see. That is x. From fingertip to fingertip, right there, that's x. Well, that's 3, and that's 3. So we're going to take x, and we're going to lose 6. So there's your width. I'm going to put W equals this. While we're at it, I'm going to go ahead and write down what we already discussed. H is 3. And now what we need to do is figure out what this little sucker is right here. We don't know what that is either, but we've got an idea. How wide is that? Well, 4x. We've already discussed it. This width is 4x, and we're going to lose 3 here. We're going to lose 3 here. And when we do that, this entire thing right there, that is 4x minus 6. And that is our length. Now you can switch your width and length. You can call them whatever you want. But to be consistent with the way the problem is worded, we'll do it that way. Let's plug in everything we know. How do you know to do that, Mr. Reader? Well, because I've done this problem before. But even if I didn't know, then what I recommend you do is set up a formula. Draw on your picture and set up a formula. Let me pause this problem for a second to talk about some problem-solving strategies. I know I said it at the beginning of the problem, but we panic a lot when we see these types of problems because we're scared to death that we don't know how to approach it. Don't worry if you don't know how to approach it. Just approach it. Draw on your picture. Write down some formulas. Plug in what you know. Grab your calculator. I'm about to. And this is going to get kind of ridiculous, but we're going to go with it. So here goes. The volume. They told us what that is. 336. Sounds like I'm about to give a phone number. Length, 4x minus 6. Width, x minus 6. Height, 3. There you go. That's it. Now, all we have to do now is figure out what values of x will give us that. I'm going to do this the good old-fashioned way, but I will go ahead and tell you, and don't turn the video off once I say this, I'm going to go ahead and tell you, you could just plug these in and see which ones will give you 336. Now, the reason I'm not going to go that way is because they might word a problem like this differently to where you'd have to go with it the long way. So, glancing, let me tell you the first thing I noticed. That number is clearly divisible by 3, and we have a 3 at the end that somebody's going to get angry about. So let's just go ahead and kill it. Divide everybody by 3, it's going to kill those. Divide that by 3, and now our phone number changes. Now it's 112. And while we're at it, let's go ahead and FOIL. So we're going to have 4x squared minus 24 minus 6, that's minus 30x, plus 36. And let's move everybody over to one side. How do you know to do that? Because he's quadratic. You can't solve this sucker until it's equal to 0. Trust me, I've tried. Unless you're doing this method called completing the square, which we're not going to do. So 36 minus 112, I'm slightly embarrassed that I can't do that in my head right now, but you know what? We're going to go with it. Negative 76. Okay. You've heard this before, but you could just say negative b plus or minus the square root of b squared minus 4ac all divided by 2a. You know what though? And you don't have to do this, but everything is even. So it'll make it a little bit easier, slightly smaller numbers if we'll divide everything by 2. And when we do that, we have that right there. Now I'm going to take a minute and just check through my work because I've flown through this very quickly and I want to make sure I'm right. I'd hate to have to make another video about the exact same thing. There we go. Yeah, we're good to go. So negative b plus or minus the square root of b squared. I'm going to go ahead and plug that in. It's 225. 2 negative 38. All divided by 2a. Oh, negative b plus or minus the square root of b squared. Let's go ahead and plug the square root in. Please be a pretty number. It's 23. I'll divide it by 4. Oh, negative b. Alright, we have a couple options here. We could add or we could subtract. Knowing that we could subtract and get a negative on the top, which would leave a negative answer, and that won't work because we're dealing with a box. I've never seen a box with a negative length. That doesn't exist. Let's ignore the negative option, and 15 plus 23 divided by 4. There we go. 9.5. What was the width of the sheet of cardboard that James started with? It was 9.5. There we go.